analysis of the frame, we can go to the design section and do the design of the elements of the frame. So let us first do the analysis of the frame. So let us perform the analysis of a 2D frame. Okay. Let us take a frame where the number of bays is 4, enter, and the number of stories is, say, ground floor and first floor. That is if that is only ground floor, then you have to write 0, but as it is ground floor plus the first floor, so we will take number of story as 1. Okay, typical height of the story we take it as 3 meters, right? Press enter. Write the width of the bay, 1, say 4 meters. Press enter. Always press enter after writing the value in the text box. Okay, 4 meters, 4 meters, and 4 meters. Okay. So no further members are to be drawn. Okay, so just click command. This shows how do we have to enter the numbers in the text box, or all the frame joints have to be number first and the support joints have to be number last. So we will do the same. Okay, the drawing is not complete. Okay, so just give the members first in the frame joints, right? These are the frame joints. Okay, and these are the support joints, right? Okay, now click finish, exit. Drawing is complete, text box are filled. Write the number of frame joints, 10. Press enter. Write the number of supports joint, 1, 2, 3, 4, 5. Press enter. Okay, 11 is support, 11 is fixed, 12 is again fixed, 13 is fixed, 14 is fixed, 15 is fixed. Okay, now let us give the member data. Say width of all the member is 0.25 meters, right? Let us select all the members together. Okay, assign the value. Depth, so depth of the beam is 0.45 meters, right? Select on. Let us select all the members. Okay, assign the value. Let us give depth to the columns. So it is 0.6 meters. Press enter. Okay, you can select all the columns. Okay, assign the value. Okay, now say suppose we have a UDL of 75 kilonewton per meter on each beams. Press enter. Okay, and you can just select all the beams manually or by this command, right? Assign. You can see the loads. Okay. Now let us save the file now, as all the data are given. Okay, let it be saved as AM. Run analysis, create input. Okay, run analysis. Say modulus of elasticity in kilonewton per meter square of material is 2E8. Press enter, and the load factors are 1, enter, 1, enter. Okay, finish the command. Okay, so this is how the frame has been analyzed. Okay, you can see the bending moment diagram, shear force diagram over here, or you can see the bending moment and shear force diagram for any individual member. Say 15, write 15, enter. Okay, now we can design these members by going to the design form. Close this form, open program list on design form, go to design form. Okay, program list. Okay, this will design all the beams of the frame. Say Fy is 415, enter. Fck is 20, enter. Limiting depth of beam is 450 mm, enter. The condition is continuous or restrained, that is, it is a frame, so 3. Okay, click finish. Yes, no editing is to be done, right? Okay, so you can see the output, right? So this is the output where all the beams in the frame has been designed. Okay, the assumption over here is that the effective cover is 50 mm. If effective cover assumed is 50 mm, right? So this is the complete analysis. Okay, right. But you can use this program also. Right? Okay, where you can vary the effective depth. Instead of 50, you can take say 40. All right, 40. Over here, you have to use tab key. So press tab key. Width we are given is 250 mm. Press tab key. Depth we are given is 450 mm. Press tab key. Fy is 415. Press tab key. Fck is 20. And you can draw the graph. Okay, so this gives the complete analysis of the beam. Okay, so for a particular moment, design moment, you get directly the percentage of steel from this table. This is the minimum steel required. The percentage of steel should not be less than this minimum steel. Okay, so this is all you know very well. So you can this is how you can design, do the analysis of the beam of the being present in that frame, right? Okay. Okay. Now after that you can come to the column section. You can open this table, interaction table. Right over here, we have 10 columns in the particular frame. Say we want to design column number 4, click column number 4, then it will this program will assume a particular effective cover, okay, and a percentage of steel and the number of steel layers of reinforcement. Okay, so this is our column, okay, where our width is 250 mm and depth is 600 mm, and the number of steel layers assumed are 4. Over here we can see the number of steel layers are 3, 1, 2 and 3. So we can change this to 3 also, or but we have to see that the distance between the two layers of steel should not be greater than 300 mm. Okay, so we can assume 4 or 3. It doesn't matter because it as the depth of the column is 600 and 50 mm we take as effective cover. Okay, so 600 minus 50 that is 500. If you give 3 numbers of steel layers, then the distance between the two layers will be 250. So that is okay, right? So this is how we can change this to anything. We can make the effective cover as 60 also, right? But please remember you have to always press enter key in this program, right? So press enter. Let you can select the percent of steel, say as 1.25. It's up to us. Okay, press enter. You can change this to a number of layers to 3 if you want. Okay, let us take it as 3, right? Okay, the width given is 250, column depth is 600, F5 is 415, F6 is 20. This is the design load, actual load which we get from the analysis, and this is the moment. So this will design the column as uh, a column with an axial force and a uniaxial moment. Okay, so let us see. Click finish. So this is the PM diagram, right? And this is where our section falls. Okay, so as the section falls within the PM interaction curve, so it is safe. If you want, you can still reduce the steel. So this is how you can design all the columns by using this program. Then you can come to individual footings. Okay, from here, this is the command which says last executed to the frame. So there are 5 footings. Okay, so you say you want to design footing number 9, right? So just click. So it takes the load over here. Okay, and these are the assume dimensions, and you just have to run calculate. Okay, so this gives the design, right? But this tables, and you can change the assume values as per your requirement. You can change this to 1.7, say, and you can change this to say 1.2, and you can change this to say 1. Okay, and depth you can change this to say 0.2. It's up to you, right? Okay, this is the assumed load factor 1.5, these are the service loads. Okay, and the weight of the foundation consider is 10% of the service load. D, this is D, that is 150 mm, and the effective cover assumed is 75 mm, right? So you can take a number of different values of this variables, and you can just calculate. Okay, then the effective depth required works out to be 0.25, and taking number of different combination, you can see the bar chart, and you can find which design is most economical. When I bring the crusher over here, then this shows the detail for that combination. If I bring the crusher over here, then this shows the alternate one combination for the alternate one. Okay, the data taken in the case for alternate one. Okay, so this is how you can directly design the elements, that's beam, column and footing, for a given frame after running the 2D analysis frame. Thank you.